For this problem, we are given f of x is equal to x over square root of 1 plus x. And the question is to find the fourth derivative of f evaluated at 0. Now, that is a problem that hypothetically could have been given in Cal 1. Use the quotient rule, use the quotient rule again, use the quotient rule a third time, use it a fourth time, and figure out what the fourth derivative at 0 is. That is doable, but it is painful. The way that we're going to do this problem is with this extra piece of information that was given here. The Taylor series of this function is given to be this. So we'll take this as a given. Use this to figure out what the fourth derivative at 0 is. Now, the way we're going to do this is that the Taylor series expansion is summation n equals 0 to infinity of the nth derivative at 0 over n factorial times x to the n. Okay, so what is the x to the fourth term? The x to the fourth term from this is going to be the fourth derivative at 0 over 4 factorial times x to the 4. Okay, so that's all well and good. Now, how about from the function that's given here? What's the x to the fourth term? To get the x to the fourth term, let's just plug in n equals 4. We get negative 1 to the third times, if I plug in 4, I get 2 times 4 is 8 minus 2. That's 6 factorial divided by, if I plug in 4, I get 4 to the third times 4 minus 1 is 3 factorial. I've got the square here. And then times x to the 4. And so these two things have to be equal. So here's your series. So if I plug in x is equal to 4, I get this. In the original Taylor series theorem, I get this. And so these two things are going to match up. And so just equating those two things, we get that the fourth derivative at 0 times 4 factorial is equal to negative 1 to the third times 6 factorial over 4 to the third times 3 factorial squared. And so the fourth derivative at 0 will be equal to, negative 1 to the third times 6 factorial times 4 factorial over 4 to the third times 3 factorial squared. Okay, now let's plug in numbers. So negative 1 to the third is negative 1. 6 factorial is 720. 4 factorial is 24. 4 to the third is 64. 3 factorial is 6. Square it, you get 36. And so just plugging into a calculator or canceling, we find out that the fourth derivative at 0 is equal to negative 15 halves. Okay, so the way that we do this problem is that we remember that this expression here is basically the nth derivative at 0 divided by n factorial. And in the case of n equals 4, I get these two things, which I then set equal to each other to be able to solve for the fourth derivative at 0. There's nothing magic about the number 4 here. The same technique could have been used to find the fifth derivative, the 10th derivative, or any derivative that we wish.